So this is a continuation of our notes that we did today. So I'm just using a new piece of paper because I have some of this in my notes already, but I'm really kind of like down here underneath the equation that we just left off. And we're talking about the derivative and the tangent line. So we get here a definition of a derivative. And we're going to see that there's a couple of ways to find a derivative as we go through. And sometimes you'll be asked one way or another way on how you have to find the derivative. So I want you to be watching if the directions ever say use the definition of the derivative. That means that you're supposed to use this limit definition. And we've talked about this already, so we're just kind of summarizing here. But this is the definition as long as the limit exists. Remember that earlier we talked about some instances where a limit would not exist. And we'll come back to this and we'll see some more examples of where that might happen. And before I forget, AP Classroom, you have to sign up. Our AP coordinator is not happy with us. So let's get that done. Okay, so let's look at the next part here. On what does it mean when we say a function is differentiable at a point? And the key wording here, because again, that might come up in a question. And what we want, all you need to know is that it means that the function has a derivative at that point, or that the limit exists. And so if I'm thinking about that the function has a derivative, I'm thinking more of that the limit exists. Again, we will get into problems where we can look at, well, we saw some cases like if there was a sharp corner or it was oscillating or maybe there was a discontinuity. And we're going to look at some things that we can tell mathematically if a limit exists or not. So for right now, I just want you to note that if something is differentiable, that means it's got a derivative, and a derivative means it has this limit right up here. Okay? Now, as we're going through with these derivatives, we're going to see that there are a lot of symbols. And we just got to be aware of all of them. Okay, the most common one is f prime of x. I'm going to say the second most common is y prime. We also might say find dy dx. We might say find df dx, the derivative of the function with respect to x. And sometimes we might write d dx of f of x. Okay, all of these symbols right here are telling you do that. Okay, so you just want to get those two plugged in together, that they go together. Okay, so now I'm going to go off of this paper, and I'm going to go to page 4 in my notes for chapter 2 here. And let's look at an example. Okay, so this is asking us to find the derivative of this function. And right now, we're going to use the definition of the derivative. Again, the derivative is just saying, find the general formula for the slope of the tangent line. That's what this all means. Okay, so when you do this, it's important that your notation, you look at what they asked you for, and you're going to say dy dx equals. Okay, so it's important that you have that there. So I'm going to say it's the limit as h approaches 0. Okay, so in here, I'm going to go to that formula that we had. And I'm going to put x plus h squared minus 3. Okay, so we had f of x plus h minus f of x. Okay, that's f of x right there. Okay, the biggest mistake in pre-calculus when we did the difference quotient was right here. People forgetting that they have to distribute that minus sign. Okay, so this is all they want us to find. Okay, so let's clean this up. Well, this is going to be x squared. Don't forget, we're squaring a binomial. Okay, so that is the limit to x squared plus 4xh plus 2h squared. I'm going to get rid of those for right now because I don't need those. Minus 3h minus 2x squared. Okay, let's see. Those are gone. Okay, looks like that's it. So we have 4xh plus 2h squared okay. I'm going to factor out, because if I plug in 0 right here, I'm going to get 0 over 0, indeterminate form. I'm going to factor and see if I can reduce. Okay, so we have the limit as h approaches 0 of 4x plus 2h minus 3. Now I'm going to plug in the 0, so just for h. So I'm going to drop the limit symbol, and it equals 4x minus 3. So that is what dy dx. And all that is the general formula for the slope of the tangent line at any, at any point, sorry you guys, on the graph. Okay, so now I want you guys to try this one. So you're going to do the same thing. You're going to find f prime of x, which is this just another word for dy dx, if f of x is equal to x squared minus x. Okay, and just I'll put a little note down here that you should get two x minus 1. All right, so pause the video and work on that. And that's it.